All right. I think I'm audible to everyone, right? Hello. Great. Hi, everyone. My name is Riya, and I work as a software engineer at Microsoft. Today is actually the first time I'm in Folkestone and first time attending C++ on C as well. I have attended a lot of conferences in the past all over the world, and this is easily the room with the best view. Like I can, please forgive me if I keep looking outside Diamond again and then try to speak. But yeah, anything apart from that. Today, I will be talking to you all about temporal dynamics. We will be embarking on a journey through the world of basically special member functions, and we'll talk about their impact on the life cycle of objects. Pretty much all the examples I will took is what I worked on a project at Microsoft, and we kind of come across multiple issues while working, and we had to do like a lot of memory optimizations, and I had to sort of look into the part of how can we really optimize and work out a way where we could make our memory and how do we work with objects in a far better way than how we have been doing so far. So we'll talk about some sophisticated aspects of C++ object management, and then we will also see some advanced techniques and best practices that you can also use when you are also working on a similar situation. Obviously, the examples that I will be showing a lot of code over here are pretty much my own. I've sort of tweaked it a little bit because of Microsoft confidentiality, but yeah, you will be pretty much be able to understand what I'm trying to say. Okay, so let's get started. Now, to understand everything in a better way, I have taken a direct use case over here, and I'll just pretty much dive into the code. And we are going to imagine for the next 1 hour that we are maintaining a pool of database connections. And you can see in the code that each connection is sort of like a complex object that must be managed, as you can see, carefully to ensure that the resources are properly initialized and released as such later as well. So here we'll go a little bit, I would say basics first, just revisit very quickly special member functions, and then I'll dive into what exactly I wanted to talk about in terms of optimizations. So you can see in the first case over here, I've taken a very simple, very basic default constructor, which is a constructor that you can call with no arguments. And its main role is just to initialize the objects of a class. Now, when you define a class without any constructor, the compiler will automatically give you a default constructor as well. However, if you define any other constructors of your own, the compiler does not generate a default constructor unless you specifically declare it. Now here you can see I have created a class, which is a database connection class, and the default constructor initializes the new object, right? And this might set up default values wherever I want to and whenever I want to establish a connection with the database. Second one is again very simple. I have taken another special member function over here, which is a destructor. And again, a destructor is going to be again automatically called when an object goes out of scope, right? And or is maybe explicitly deleted. And its primary role is going to be doing some cleanup tasks for us and release resources that the objects may have acquired during its lifetime. In this example that I have taken over here, the destructor sort of ensures that the resources associated with this database connection gets cleared up, right? Wherever you can say, like whenever I am doing some file handling, right, or some opening connections and I want it to be released later, I would be able to do that. So this will basically ensure that I do not have any resource leaks, right? And I do not come across any issues later, which can sort of hamper my code flow. Next, I have a copy constructor, which is a third special member function that we have, right? That initializes a new object as a copy of an existing object, right? Now, it is called when you want to create a new object, right, from an existing object, and such that when you're passing an object by value, you are basically returned an object over here. Now, for this database connection example that I have took over here, the copy constructor creates a new database connection with the same state as the original object. However, duplicating this connection state over here in this example is very undesirable because database connections typically represent unique resources, right? Every connection I create for my database has to be unique. So in this case, I would not really want to have copy constructors, right? Because these resources are unique. I would not want to, meaningfully duplicate them, right? And copying such resources can also lead to multiple objects trying to manage the same connection handle in this case. So this could again lead in resource conflicts, but just for the example purpose, I've shown how could we write one if we wanted to. Next is going to be a copy assignment operator, which is going to be our fourth type of special member function, which is used to assign the state of one object to another object if I want to. And it is basically called when an already initialized object is assigned, right, from a value from another existing object. In this example that I have taken, you can see that the copy assignment operator would assign the connection state of one database connection to the another. Now, this would involve at this point, you can see in the code, a very careful management of the connection state to avoid the resource conflicts in this case as well. So yeah, this would be our fourth, I would say, special member function, which I have introduced. The next is going to be the move constructor. Now, the move constructor is again a special constructor for us, right? That will enable us to, that will enable the resources owned by a temporary object. Let's say R value is my temporary object, to be transferred to the new object. So unlike the copy constructor over here, right, the move constructor will essentially move the resources from a temporary object and it would be transferred to a new object. Now, this would basically help us to avoid the need for expensive deep copies and allow us to, sort of essentially transfer the resources, which is particularly useful for, objects which are managing unique resources such as database connections, as was my scenario as well. In this case, you can see for database connection over here, the move constructor allows the transfer of the database connection handle from one object to the another object without duplicating the connection. Now, this is very important. Why? Because first, database connections represent unique resources, which I said should not be ideally duplicated, unlike we did in the previous example of the copy constructor. Another thing is transferring ownership of a connection handle, right, is basically more efficient than actually copying it. Please let me know if I'm going too fast. I'm usually very excited while giving a talk. So if it goes fast, just let me know. All right. Next, we have, I think, the move assignment operator, which is again a special member function for us that will transfer resources from one object, right, to another object. Basically like a temporary object for us to the left-hand side of the assignment, whatever you have. Now, this will also let us to efficiently transfer the resources without the need of expensive deep copies. In my example that I have taken, the move assignment operator sort of allows the transfer of a database object handle from one object to another existing object. So here, the another object is also already existing. I simply want to transfer the connection from one object to the another object. Now, this is again very crucial. Why? Because I want to avoid eventually the overhead with deep copying of unique resources again and again. Again, if I want to do proper resource management, I would want to try to transfer ownership, right? And I would want to, at the same time, invalidate the source object as well. So basically, the point is that by basically implementing all these special member functions, right, I want to make sure that my resources are efficiently managed, right, and my performance is also optimized. Now, this is very basic and you will find like a lot of resources online already to, learn about these as well. And people try to sort of work with these ways and try to implement all these 6 special member functions. But that does not eventually just guarantee that you will have a very optimized code base and you will have a very optimized working of your entire system. Efficient way to use these special member functions and knowing where they fit well, right, and where you can sort of automate this entire process is what is very crucial. And that is where we actually started going into different, I would say, ways and different options to figure out how we can actually make it better, which is what we are going to discuss as well. So yeah, just to quickly realign, I think we discussed 6 special member functions at this point, right? And those are basically implemented in a very simple scenario right now, which we are trying to now going to optimize and see what we can do better. Now, although this may look like we've done a lot already, right? We're just like sort of getting started now. And there are a couple of rules, if anybody already knows about that, that sort of guide the developers in C++ to write more robust and more maintainable and efficient C++ code. And these rules sort of address the complexities of resource management. So we'll talk about 2 rules over here. We'll talk about rule of 6, and then we'll talk about rule of 0. Rule of 6 is very, very simple, right? The rule of 6 simply says that if you have any of these special member functions in your defined class, you probably need all of them as well. Okay, so the rule is very simple. Like, it sort of is, I would say, a forwarding point from rule of 5. And it says that if your any class has any of these special member functions, you probably need all 6 of them as well. So the reason why we introduce rule of 6 is because we want to ensure that the class handles the resource management without any unexpected behavior that may come later. Now, by adhering to this particular rule, we ensure that the database connection class that we created in the start, right, it manages resources consistently and safely. So yeah, this would be our rule of 6. The rule of 0 that we will introduce and sort of see being implemented over here on the same class itself, that it simply says that while designing classes, right, it suggests that we basically design classes in such a way that the compiler generated special member functions suffice without the need to define any of these functions. Okay, so this is basically achieved by RAII, which is simply resource acquisition is initialization. I will talk about that as well. And by smart pointers, which are very important. It may look like a lot of jargon right now, but when I will just sort of I will divide this code further, you will see that then it becomes a beautiful picture later. But yeah, these are the two things which the rule of 0 says that you should have, which is RAII and smart pointers, which will make your code far better, and you would not have to, I would say, explicitly define all the 6 special member functions. Now, the reason why this rule specifically exists is that you can reduce the complexity of resource management. Repeatedly implementing special member functions may not be the best way to do it. Your code will be more maintainable and it will be less prone to the errors as well. Now, the compiler generated special member functions that you have are sufficient, and the resources are then managed automatically as well. Now, to contradict this point later, we will also talk about some customized destructor strategies also. But yeah, for the timing, I think this is what rule of 0 tries to help you to understand in this case. So you see std shared pointer over here, that is a smart pointer, right? And then you see, we'll talk about a weak pointer also, which are again smart pointers, which we'll introduce. The main reason this rule exists is sort of that you're encouraged, right, to design classes that rely on these two concepts, right? So it will simplify your overall management cycles. And again, the likelihood of errors are practically very low when you use this kind of implementation. All right, we'll talk about RAII. Just to give you a very basic, it's just an idiom in C++ that tells that the life cycle of a resource that ties the life cycle of a resource to the life cycle of an object, right? So whatever resource you have, right, its life cycle will be defined by the object that you have. And for example, memory, file handlings, network connections, everything like that. So the idea is that the resources are acquired and initialized in the object's constructors. And if you want to release the resources, you do that in the constructor itself. Let's see a few principles, and then I'll show you like good examples to show this. 3 principles on which it is based on: resource management via object lifetime, exception safety, and encapsulation. Very beautifully put together, right? The first point is very simple. When you create an object, it will acquire a resource, obviously. When an object goes out of scope, the destructor should be called, releasing the resource altogether. The other one would be exception safety, right? Since destructors are automatically called, right, when an object goes out of scope, right, resources are always released, even if the exception is thrown. So it may happen that you did something with your resource, but the exception came into the picture, but you still want to release the resource because you had, the resource basically went out of scope. So I would really want to do that. And then it also prevents resource leaks and ensures that the system remains in a consistent state. Personally, when I was working on this, exception safety was very, very important. We came across a lot of issues into this, right? And then we had to sort of come up with this and sort of implement it in a way that we are able to, take care of the part where the resources are being freed up quite early. And then we have encapsulation. Now, RAII says that encapsulation basically should do your resource management within the classes itself, okay? So that your code is easier to understand, so that your code is easier to maintain as well. But if you will see that in the very start, I have just sort of tried to create a class over here, which will sort of be connecting with the resources. And then I've just done the basic acquisition. So when this database connection object is created, the constructor sort of tries to get the resource. So I have basically passed over here the connection ID, as well as I've also passed in an attribute over here to see if basically we can establish a connection. And then I have done the initialization over here. So the object members, basically two object members over here, you will see one is connection ID and the other one is going to be is connected, is sort of initialized to represent the established connection. So I have done database connection, I've passed in the ID, I've tried to also pass in if we are connected or not, and then I've just simply tried to print it. I've said connection connected, and then I've tried to put the connection ID as well. The idea being we do two things over here. We acquire, we do acquisition as well as we do initialization. With acquisition basically means that we try to have the constructor which will acquire the database connection, as well as the initialization that we also have to do over here. We do that to represent the established connection that is created in this case. Another thing that I have done over here very low is how I have disabled the copy operation as well as I have enabled the move operation. Like I was saying in the start, I would not really want to have multiple objects clinging to the same, I would say, resource, right? Because that is pretty much not the ideal scenario for my case. So what I will do is I will try to disable the copy operation, but I will enable the move operation. So what I've done over here is I've dropped in a small comment saying that I would like to disable the copy operators, right? And then I have sort of put it delete. And then similar thing I have done for the move operations. For the move operations, I've tried to enable it so that the moving of resources is essentially enabled in my scenario. Again, what we're doing over here is resource management, particularly in RAII. And then in the very start, you will see there's a destructor also. In the destructor, pretty much I'm trying to release the resource. What the 3 points we discussed in the start as well over here, right? We would want to make sure that the object is acquired and it's initialized in the constructor, right? Essentially, we want to make sure that we do not move the resources around and we don't allow multiple objects to be clinging to it. And then if we want to release it, right, we do the releasing part only in the destructor itself over here. So these are the 3 things, and I would say how do you work on RAII whenever you have a specific use case and you would want to make sure that the object lifetime is being basically tied to the resource over here as well. So that is what RAII is. Next, we have the smart pointers. Again, for smart pointers, I will sort of try to go to a similar example itself. But smart pointers, again, allow you to do automatic memory management by encapsulating the raw pointers in a class, and then they try to manage the object lifetime using these pointers that we have. Now, this will again help us to prevent memory leaks, dangling pointers, and double deletions. The first one that we have is a unique pointer. There are 3. We have unique pointer, we have shared pointer, and we have weak pointers. First, we'll talk about unique pointers. Now, unique pointer says only one smart pointer will basically own the resource, and the resource is automatically released when this pointer goes out of scope as well. Let's see an example as well over here. I hope this one is clearer, right? Okay, in this example, what you will see is I've tried to implement unique pointer. In this connection pool, each connection is typically managed by a pool manager, right? So I have created over here sort of like a connection manager for my database connection class over here, right? And each connection should be exclusively owned and managed by a single manager object for me over here. Now, unique pointer is ideal for this purpose if you have a resource like this where you have a connection and you would like to put a connection manager over it for 2 reasons. First is exclusive ownership, right? Only one unique pointer can sort of own the connection at any point of time. Now, this prevents multiple managers also from trying to manage the same connection, which will avoid resource conflicts for us. The other thing is resource management, automatic resource management, where you will see that this pointer, if it goes out of scope, it automatically cleans up the resource for us. In this case, the resource is going to be the database connection for us. Now, this ensures that the connections are properly closed and they are cleaned up whenever the explicit delete calls are basically coming into the picture. So unique pointer will basically help us to make sure that only connection manager which has been created is sort of owning that particular database connection for us. Next, we have shared pointer. Now, shared pointer says that we will have a shared ownership, meaning that multiple smart pointers can sort of share the ownership of a resource. And then it says reference counting, which means that a resource is released the moment when the shared pointer owning is basically destroyed. So, let's say if I want to look at an example for this as well, I've taken a slightly different example because that wasn't fitting in my use case. But you can see I have a config over here and then I have a session class over here as well, right? Now, in let's say any server application, like going off from the database connection example, it is common for multiple sessions or maybe multiple requests to acquire the resource in the same configuration settings, right? So these settings might include database connection strings over here that we can have, right? And along with that, you could also have API keys, you can have app settings and a lot more other things, and other some shared data also. Now, if I want to load these settings once and share them across the sessions which are all created, right? Because now I have multiple database connections, but all of them would like to have the same API keys, all of them would like to share the same connection strings, right? And could be other data that they share, right? So it is useful to load these settings once and then you could just like share them across all the settings rather than individually loading these for each sessions. For if I have a database and I have, let's say, 200 database connections, right? I would not essentially want to load these config settings in like 200 sessions and 200 connections. I would ideally want to load them once and be able to share these across multiple sessions. So that is why in this use case, shared pointer is fitting very well. First, we have support, we are supporting shared ownership, right? Multiple pointers instances can sort of own the same resource. And this is perfect when you want to share specifically configuration settings in this case. And then you have automatic reference counting also over here. So if you will see that you are able to keep track of also how many shared pointer instances basically own a resource. Now, these resource is automatically released when the last shared pointer owner is destroyed. So until and unless even if one single connection is opened, this particular pointer is going to stay in the picture. And again, I think the last point, which is very important, is ease of use over here in this. It's very easy. It simplifies your resource management by basically trying to automate the life cycle of shared resources. So again, you don't come across memory leaks when you're doing implementation like this. Okay, last one is going to be our weak pointer. Now, weak pointer basically says that you try to reference a resource managed by shared pointer without actually using it, and then you try to prevent cyclic references. So you try to avoid memory leaks, which are caused by cyclic dependencies in this case. Let's say we take an example over here. Here, I've taken an example of a publisher subscriber model. I'm sure all of you must have used queues at some point where we have a pub-sub model where someone is publishing something and a bunch of subscribers are there for that particular publisher. So in a pub-sub system, what happens is a publisher maintains sort of like a list of subscribers that they have that should be notified of several events that are basically happening, right? Or if there's a change of state in the publisher as well. So in this case, the subscribers need to reference the publisher to register or basically unregister themselves if they want to receive the updates. Now, using shared pointer over here in this example, what we can see is that the publisher subscriber system can lead to cyclic dependencies, right? Where the publisher is sort of holding a lot of shared pointers to subscribers, and subscribers also are sort of holding those shared pointers back to the subscribers and publishers in this case. So in this case, you can see that the mutual ownership sort of creates a reference cycle for us. So preventing the reference count from actually reaching zero. So here, by using this, you can do three things. The first is you can have non-owning resource references. Basically, you allow the subscribers to reference the publisher without actually owning it, right? So this means you have weak pointer and they do not affect the reference count over here. The second thing is cyclic dependencies you can easily avoid. By using weak pointer, you prevent the cyclic dependencies between the publisher and the subscriber. And then you have save access, right? So the good thing is weak pointers can actually be converted to shared pointers as well temporarily to basically give safely the access to the publisher, ensuring that the publisher is still valid. So this is an example of a pub-sub pattern over here, right? I have a subscriber and then again it is being using first the shared pointers, right? And then if we want to notify, I have that functionality to the subscriber, right? Parallelly, I do have that functionality same to the publisher as well over here. So if I want to add a subscriber for a particular publisher, I can do that. And if I want to notify the subscriber also, I should be able to do it. Eventually being able to convert this weak pointer to the smart pointer, shared pointer as well. So this is pretty much how you can try to use shared pointers. I think the three examples that I took, where we have unique pointers, shared pointers, and I would say weak pointers, are basically the way you try to make your resource management a lot better in this case. So I think this example that we also took was about, I would say, again, a smart pointer that we had, right? And then again, when we have shared pointers, we talked about it, we had gone back to the unique pointers references over here. So smart pointers will basically allow you to do that automatic memory management by encapsulating the raw pointers inside a class that you have. You will see all the examples that we took. We pretty much had smart pointers encapsulated inside the class, which will manage the resources lifecycle for us. So using these both, using basically RAII as well as smart pointers, you can basically try to understand the rule of zero and then try to have a similar implementation if trying to implement this in your code. So now we will go ahead and talk a little bit about move semantics. Now we have understood rule of 6, we have understood rule of 0, and they are helping us managing our resources effectively. We'll transition now to another aspect, which is move semantics, and we'll try to understand it. Move semantics basically takes your resource management to the very next level, what we have been doing so far, to basically allow you to efficiently transfer the resources, which is particularly important when we have high performance backend systems, which I was working on. So my system, when we were working on it, the scale was very high. So we essentially wanted to make sure that the ownership keeps getting transferred and we don't have to create a lot of deep copies. So that is what we came across on move semantics at that point. And then we basically try to take the ownership over here to the next level, but we do not really want to, I would say, perform a deep copy, which is very, very expensive. And to understand move semantics the best way, we need to know the concept of perfect forwarding. Now, perfect forwarding is actually a technique that allows you to forward the arguments to another function while preserving their own value category at that point. So if you want to design template functions at this point, if anybody has done it, that comes very, very handy over here, that accepts any type of argument for us, right? And then they basically forward them to the other functions in a very optimal way. You will see in my example only over here, which I will just show, the move constructors and the move assignment constructors are basically crucial whenever you want to do effective, I would say, resource management. Now, if I want to do the transfer, it sort of works in a similar way over here. Let's say I have this database connection class, okay? Now over here, I have the move constructor over here, which is going to be in the second one, which will efficiently transfer the connection string, right, for us from one source object to the another source object, leaving the resource in a valid but unspecified state. The second I have is the move assignment operator over here, which will sort of transfer the connection string in this case that I have taken over here from one object to another, ensuring no unnecessary copying has to be done. Because if I'm trying to transfer the ownership, I do need to transfer the connection string. And then you can see the deleted copy constructor over here, right? As well as I have also deleted, in this case, the copy assignment operator. You will see that I will try to enforce move semantics now to basically prevent some accidental copying that can happen, which is like more expensive and less efficient in this case. So by doing all these things, right, by trying to understand your use case, what you can see is that the move constructor and the move assignment operators are very crucial, right? You try to transfer the resource from another object to the current object, right, without performing a deep copy in this case. We also have a no, I would say, except keyword in this, right, which sort of indicates that an operation is basically guaranteed to not throw any exceptions, right, which is essential as well if you would like to use it. But yeah, these three, I would say, operators that we have used, or I would say special member functions, move constructors and move assignment operators, sort of try to help you in this case. But at the same time, you also have to know that you need to delete the copy constructors and copy assignment operators in this case to know that the perfect forwarding is happening. And then eventually, in that case, the move semantics are working well as well. specifically for this database connection string example that I have taken. Another thing, what you could do is you can also do perfect forwarding with STD forward over here. So I have used another use case over here. You will see pool dot emplace back, and then I have done STD dot STD colon colon forward in this case, right? So there is an add connection method that you will see over here that I have created that is used as a template, right? And the STD forward inside it, it's sort of used to perfectly forward the argument to this emplace back function over here in this case. So emplace back function that will eventually take and try to add it into the database connection pools over here. So this will ensure whether the argument is a L value that or it is a R value, it is forwarded in the most efficient way in this case. If a R value is passed, right, for example, here I've done STD forward generic T and then connection. This is sort of like a R value for us, right? And then we are using emplace back, which is going to essentially use the move constructor in this case to which is going to be very efficient for us. Now, usually you will see that the move semantics as well as the perfect forwarding that you use, the resources are transferred efficiently without unnecessary copying that I have to do. And this will improve the performance as well as the scalability of your backend applications, especially when you're dealing with expensive to copy resources operations a lot. Now, that happens a lot when you're using database connections. Now, you try to enforce move semantics in this case, right? And then you try to always leverage perfect forwarding as well. You can write more efficient and more maintainable code in this way. All right, now that we know everything about here, another use case that we had, which was very good, and we tried to work more at this, is that we try to bring in more customized destructure strategies, right? Although a lot of it is being handled automatically, even if you used shared pointers and you try to work that way. But even I would say going into that, having customized destructure strategies is also very important, and they play a crucial role for us in resource management, ensuring that the resources are properly released, right, when an object goes out of scope. So not using the default ones, but you can also try to design on your own, right? In any complex architecture that you will go into, you will see that the crafting specialized constructor becomes very essential when you want to sort of the resource reclamation in this case. So three things over here. We have three strategies in this case as well. We have resource reclamation, which we want to do essentially if you're trying to design it of our own. Another point which I talked a little bit about the start as well, you would want to keep it exception safety. You would want to make sure that even if you come across some errors, but the resource has gone out of scope, you do not want to hold on to that resource still at that point. You would want to release it. And the third is we have different nuances of object destruction at that point. Okay, we want to make sure in the very first point that the resources are reclaimed whenever an object is destroyed. Repeating the second point again, we have exception safety. You want to make sure that the constructors do not throw any destructors, do not throw any exceptions and leave the system in a consistent state. And the third is managing dependencies between the objects that could come and you're trying to delete a particular resource, right? So you want to make sure that the correct order of destruction is being followed in complex architectures that you are working on. Okay, so here you can see I've taken sort of again an example going back to the database connection and the connection pool example that I had. You can see we are iterating over here. So this is the customized destructor that I have created on my own. I'm iterating simply over all the database connections which I have basically created, right? And I'm explicitly calling the destructors for all of those connection pools or basically all the database connections which I basically opened. I am also logging a message over here, right, for myself to basically make sure that whenever a connection pool is being destroyed and the connections are being cleaned up. The third thing that I'm also doing is I'm ensuring that the resources are properly released. I'm trying to maintain that the exception safety is also in the picture, right? And I'm handling the destructor order correctly as well. This is a small example, but if you're working on big systems, you should be able to sort of release the resources in a far better way as well if you have a certain ordering that needs to be followed. So basically, by, I would say, customizing destructors in such a way, you ensure that the resources are being managed by an object are properly cleaned up. And you do not come across any memory leaks. You do not come across, you have your system far more maintainable while what we had earlier in the start. So I think one of the biggest learnings that we had in this kind of a system and when we were building this is that not just knowing what the special member functions was, but also understanding how do we really need to use it. Because every use case that we had, especially for our database connections, we were dealing with millions of users. And even at that point, after that, we were also dealing with a scenario where we wanted to make sure that, we don't have a lot of connections being opened up and we do clear out the resources quite frequently, right? So that is why we had to sort of come across with these strategies and we implemented all of these, and we did see that our systems were far more maintainable and even the code structure was far more maintainable when we were implementing a system like this. So yes, I think that is pretty much what I wanted to talk about over here. If you will see that all the things that we covered, the first one is what we talked about as the smart pointers, and then we moved on to the rule of 6 and rule of 0, right? Rule of 6 is pretty much very simple, right? You just simply say that if I need one thing, I pretty much need all of 6 as well. But again, when we move out to rule of 0, we say that you don't need to explicitly do this. There would be a lot of memory management, or there will be a lot of things that can automatically being handled by a compiler. And then when we talk about rule of 0, two things which becomes very crucial is RAII. That is, and again, we see like three more different things in it. And then we talk about smart pointers. And the amalgamation of all of this is pretty much what comes us to the final scenario and helps us to understand how the resources are being moved very efficiently in this case. And then I just wanted to also talk a little bit about the customized destructure strategies in this phase as well, right? Of how you can implement this. Again, this was a very small use case that I think would say came across later in the cycle, but yes, it also helped us to sort of understand how could we do this, and it could also be a efficient way on working with this. So yeah, I think this was my a little shorter talk than usual, where I wanted to talk about how exactly we can do all of this. This was all our personal learning. So I think the moment I graduated, I was just given this problem quite early. So this was a very good learning curve for us and for our entire team to sort of see that how can we work with these scenarios, and then trying to understand how do we go not just at the surface level things to understand what the objects are, but we try to go 2 to 3 layers deep and then try to see how we can work with all of this. Obviously, in I think your use case may not be as I would say directly, I would say applicable over here. But yeah, the overall idea remains the same, that you understand what the system requires at that point, and with that, the system also knows that, or you basically know how exactly do you want to tackle with those problems, and then you try to work on it. So yeah, based on your use case, you can try to design a system which is different from yours. But yes, this was what I worked on, right? And this was actually worked out very well for us, and this is what we worked on. Yes. Thank you so much. Thanks for coming. Oh. Yeah, I think it's very hot. Yes. But yes, thank you so much, everyone, for coming. I hope you were able to know at least one thing new by this talk. This was a very good experience for me working on this. And yeah, I'll be happy to meet you all later as well. Thanks.